But up next, we have two speakers coming together. First is Paco Nathan. He's the managing executive partner at Derwin AI, but I actually know him better as a pretty popular author in the tech space. I saw his name on a few O'Reilly books in my bookshelf, actually. And he's been pretty prolific, both blogging on the internet as well as in the space of knowledge graphs. And with him is Jurgen Muller, who works at BASF, actually the head of knowledge architectures at BASF. And I believe from what I've seen on the internet, you guys have been collaborating for quite a bit on knowledge graphs and knowledge architectures. So I look forward to seeing how you integrate your knowledge in AI.
Great. Okay, I'll be quick here because I think Jurgen has the better part of this talk. Thank you very much. We at Derwin, we do a lot of work with graph technologies, and I was really grateful to see that there was references earlier to graph technologies being used in this space. Certainly statistical relational learning, the use of Markov networks, that's a kind of probabilistic graph. And in fact, we use a variant of that that's called probabilistic soft logic. And then there's also the mention of doing reasoning. Certainly, Prolog and the mention of like non-monotonic reasoning, and that's a kind of axiomatic graph. We do something relatively similar as well. But of course, working in industry, working in enterprise, there's generally some very large data lake involved. And the question always comes up, you're doing this stuff with graphs, why can't you just use SQL instead? So we wanted to introduce real briefly a bit about why do we use graph technologies? Why is it important in this space for physical work? So just imagine that you're in a small village, maybe somewhere in a medieval village in the Black Forest, and we're going to build up a representation here for the village. We've got Pat. Pat runs a pub, and Pat has a couple of friends, Hannah and Thomas. And then Hannah works the fields, grows grain. Hannah has a friend, Hayden. And Thomas buys grain from Hannah. Thomas raises poultry, so eggs. And Thomas also has a friend, Brenda. And then Aiden, going back, works the mill. So the stream's running through the town, the mill grinds the grain, produces flour. Aiden has a friend, Chris. Going back over here to Brenda, Brenda also buys grain and runs the brewery, produces beer. And then Brenda has a friend, Kim. And then down here, Chris works the bakery, produces bread. So Chris is buying flour, is buying eggs, and producing bread, which is sold off to Pat up there in the pub. And then Kim runs the recyclery, which takes organic waste from the bakery, from the brewery, and produces fertilizer for Hannah to use in the fields, to optimize the yield in the fields. And so the thing that you see about this is, getting ahead of myself. The thing that you see about this is here we have 7 nodes in a graph, and I'll speak up or.
No, you get my mic now.
Okay, we'll switch.
Battery.
The thing that you see here is that you've got just 7 nodes in a graph. It's representing 7 different cottage businesses in a village. But yet you've got a circular economy that's defined. And we've also very explicitly represented what is the supply network that's being involved in this community. Now, if we represent it here as a graph, it's very natural. We can understand what's happening with the flows of what's being produced by whom and how it's being consumed. If we try to represent this in SQL, into a relational database, if we normalize this, typically you would end up with about 6 different tables here, and you've got your primary keys and your foreign keys, and you can see the ERD diagram there and all. And this is how you would do it properly for a relational database. But the problem is that it really atomizes the perspectives, the view of what's going on in that village. And there's a lot of numbers, and it works very well. You can calculate with it, but it doesn't convey to somebody who really understands what's happening in that economy. And so for complex problems where you have, say, more than 7 elements, network views bring the data closer to people who can really make sense of it. So these domain experts that we've been talking about, how can they really work with this data? And visualizing the business model, also trying to identify emergent patterns that are showing. That's been mentioned a few times earlier in talks. And making informed decisions based off of this. Now, I've been really focusing just on the representation of what's happening here. But graphs also work, of course, in terms of the reasoning, in terms of coming to decisions. So one thing you can think about is maybe this village is going along very well. What happens if there's a drought, the river starts to run dry, the mill doesn't run as well, it doesn't produce as much flour? Where are the priorities shifting as far as who gets allocated water? Does it go to the fields? Does it go to poultry? Does it go to the brewery, etc.? So we have to take into account what could be some exceptional problems happening there. And I want to bring this up because how many people have ever heard of Cynefin? Anybody? Right. Okay. You've probably heard of it from Donald Rumsfeld's famous or infamous Unknown Unknowns. In 1999, Dave Snowden was at IBM Consulting, and they came up with this notion of a Cynefin framework for describing business decision contexts. If you have a very simple kind of decision-making context, then your priorities are, first off, you establish what are the facts, and you categorize what the needs, and typically can work with best practices. So somebody who's relatively unskilled in terms of data analytics can just apply some rules. Once you get into a more complicated business context, you have to assess the facts. You have to understand, do you believe them? And typically you have more experts going in and doing data analytics, doing analysis. And this is to help inform decision makers how to respond. When you get into a complex environment then, under Cynefin, then really your options are you probe the situation. You have to kind of experiment with it, find out what do you or not believe in it, how much do you understand, how certain are you. You have to make sense out of the patterns that are emergent, and then the decision makers are making informed decisions based off of that. There's an analogy in this in terms of cognitive science, in terms of cognitive psychology, how people learn. There's a really great introductory book by Susan Ambrose. The idea is that when people start to learn a new kind of field, they typically start out with a few disconnected facts, and they start stringing together the facts. When people become more of like an advanced beginner, they can put together a lot of chains of association, putting together the facts. When someone becomes more of a competent practitioner, they begin to have cognitive models that resemble decision trees. And so they can start out with some facts and work their way down the hierarchy of the decision tree. But the thing that distinguishes practitioners from experts is that experts know when to break the rules. They know when to go into those trees and go from what would have been a rote decision, go back and change it. And when you do that, you get cognitive structures that resemble graphs. And so this goes back to Cynefin. The idea is when you get into a complex business decision environment, you see where really you need to have the experts come in and describe what to do, make sense out of it. And to do that, they need to leverage the emergent patterns. So we wanted to try to show this idea of using graphs, how this fits into business decision making, but really how it fits into learning theory. And with that, I will hand over to my colleague, Jurgen Muller.
Yeah, and welcome also from my side. Yeah, as we already saw, from that small example with that village, how to link that to the real world. What I have here basically is the production of one of our products. And what we see over there is just an arrangement of 4 different ways to produce that. So basically we have this bill of materials. We have about more than 200,000 products to produce. So this is just one, which is produced in India, in Indonesia, in China, and in Thailand. And just represented in that way, like, let's say, the different ways to do that. So the red dots are the, let's say, raw materials. We have the intermediates. The blue dots are byproducts coming out. And in the middle, we have here the end product and those 4 bill of materials represented. And I mean, today, of course, we see, let's say, due to the economic situation, etc., we have the energy impact, we have material shortages, etc. So you have to deal with a lot of problems in parallel in optimizing those bill of materials in a way what can we produce in a different way, so that we still maintain our profitability. And when you arrange it in this way, that was just a drawing by hand more or less, but you already see a lot of recursive patterns where we see, let's say, same input materials coming in, etc. What I did basically was more or less a similar bill of material in a different way, represented underneath in a hierarchical form. So it starts over here and unfolds level by level. It's easy to navigate through that, but you don't see any of those patterns anymore. So that visual component of how we present things is of course also essential in the communication between maybe what models can work out and what experts can see and validate and justify and make corrections with. And those tasks, I mean, is basically what we have today said, that maintaining complexity at that level. I mean, these bombs have a level of about, it's about 8 levels deep. So we are also having production chains of, let's say, up to level of 25 and so on, where we have in a single bomb bill of material, for example, some 4,000, 5,000 nodes that represent different. And these are, by the way, just monthly aggregates that we see from a cost perspective. If we now would look at these things also from a supply perspective, where we have a time aspect, things going stepwise through those elements here, the dimensions, the complexity will even rise. And as it is outlined here, it looks like tree structures that unfold in those areas. But actually, behind that, I mean, let's say those red nodes that we see here are production stages, and they are executed in plants. So we could connect those, what happens in a specific plant, and connect all those dots. So all of a sudden, these tree-like structures are forming a very complex network. And now you start to think about how could you optimize that. As said, we have an overlay of energy costs rising, maybe raw material costs going up. Certain supplies are getting, let's say, are not delivered in the way we want, and we need to optimize such structures under all those constraints. And let's say these different perspectives is that I think one thing is really about maintaining, managing that kind of complexity, and that we need machines to help us in dealing with that complexity. Often it's not easy for humans to accept that problems simply go beyond the human level of cognition, but we need a way to communicate between the machine helping us and us understanding the results coming out. And therefore, I think we feel that graphs are actually a very good way of doing that. Let me see. So, could graphs be a means for communicating between human and machine, let's say, artificial intelligence? And as we already heard about foundation models, and we saw, let's say, like drawings being generated out of text, etc., could we probably use such kind of models to describe what they learned in the form of graphs, because it made it easier for human experts to digest that learning instead of just prompting and getting answers back, but understanding more or less the entire space. And what we saw in recent papers also, I mean, on one side, feeding back facts that are derived from rich knowledge graphs being crafted by humans to augment those models. And on the other hand, of course, if the machine could express what it learned in form of such networks, make it easier for the expert to make corrections and to apply those and feedback into, let's say, the learning loop again. So as a language for the communication between the human and the machine, and actually we're working on various different solutions, especially to capture also the expert knowledge in a structured way. Again, of course, dealing with the complexity to augment such structures based on ontologies and so on. So basically, the idea is what we heard today. We have, I think, the semantic web. We have the, let's say, logic. We have reasoning. We have, of course, on one side, we need to embed the probability level. So how sure are we about things? All those things could be expressed in those graph structures. The ways, okay, how could we construct it? How can we deal with that? And from the goals that we follow, like, I mean, we often do today, case-by-case optimizations. Could we use that for a more holistic way to steer our business, having everything, taking everything into account? And from this more or less best can do to something like whatever matters in a really, let's say, global optimization way. We often do those things in optimizing a single value chain for a product. But actually, as we see, these things are dependent on each other. Yeah, we use the same plants, we use the same raw materials, and so on. Those constraints are applied, of course, on a global scale, so that we actually do something like value network optimization. And that, as we already heard also today, not just occasionally in case we have a problem, but maybe ad hoc and real time in a continuous optimization of the business. Yeah, and as I already said, like, I think we need to augment the human expert by that augmented intelligence, but let's say in a close communication loop. Yeah, and let's say one goal, of course, that we follow also in the way how we present those results, to come from this cumbersome exercise of optimizing, let's say, something for a problem to an inspiring way. So giving visual, let's say, impulses that make it interesting for an expert to provide that feedback, to work with such solutions in this interactive way. Yeah, and as I said, turning the impossible into the inevitable. So what's needed to do those kind of optimizations. As I said, I think that's still an interesting field. I saw first papers now coming out with, on one side, trying to construct knowledge graphs, for example, from foundation models and so on. It's a very interesting case to follow. But also on the other hand, of course, that refeeding, so basically improving those models from human constructed knowledge graphs. And I think from my perspective, it's a very interesting field to follow, to see how we could close that loop for improving exactly that communication between human and machine. Okay.
Thank you so much, Paco and Jurgen. Wow, this is a very good mic. I'm going to put this back on the speaker stand.
There's more information if you want to follow the link there.
Yeah, so does anyone have any questions for Paco and Jurgen? Oh, right here.
Hi, I have two very quick questions. First of all, in the graph that you put up, Paco, you showed that Brenda was Thomas's friend, and Brenda makes beer, but I think Brenda's everybody's friend. I think that showed on there.
Exactly. There are priorities.
Yeah. This aside, it's a question for both of you. I found that very interesting overall, especially at the end, talking about the differences in the ways that you can present this to people so that they may be more receptive to it. I have a very general question, though. At this point, graph thinking's been around for a while, and yet it's still kind of new. It's not, people go to the thinking of relational databases as the way to approach and so forth. I don't think it has to be one or the other, but there are situations where there's advantage. So my question is, just overall, as both of you encounter different groups that you work with, how open are people to this shift to graph thinking, or how much of a barrier is there?
I mean, one of the reasons for generating the village story was actually I was frustrated about always this question, could we do that with relational databases? Yeah, when I talked to Paco and I said we need to do something about it to counter that right from the beginning. And I think what you see is basically maybe two types of people. Yeah. You have those who are really keen on solving riddles, and let's say who love someone to deal with that level of complexity, that really feel appealed by those graph structures because you see all the conventions. Yeah, and others, I think they more like more in the tabular view, so that one-on-one correlations, etc. I mean, both of course have their justification, but as we talked about, I mean, if the experts, or the maybe real deep experts, actually organize their thinking in that graph way, it's easier to motivate them to work with us, and this is basically what we target. It's still difficult to bring across. I mean, I always see that in a way, like you have a certain group that is not so appealed by that, and on the other hand, those who really jump on it. I always knew that there is this correlation. Could we dig deeper into that? And this is actually what we go for, and hopefully we get some of the others appeal to that, but in general, I said it's really a bit twofold in that sense.
Maybe for the ones who are more reluctant, just as you're describing it, just a sense of comfort. They know what they already know how to do, and if they step off to something else, they're no longer the expert in that.
That might be, but in the end, also what we see today is that the level of complexity rises. Yeah? As long as you just have to optimize a parameter to maintain your profitability, fine, you don't need that. But if you have to cope with multiple problems at once, and the complexity, it's not that obvious, that easy anymore, you need such kind of help to understand the difficult, let's say, the dependencies between the solutions.
Thank you.
Okay, thank you so much. Unfortunately, we don't have time for more questions, but it was great having you up here. That was a wonderful talk from both of you. Thanks.